Students, we have completed our syllabus or chapter thermal expansion of solids, and we have started discussing the numericals from this chapter. We have discussed numericals from coefficient of linear expansion, coefficient of your superficial expansion, and we have started discussing some numericals from the volume expansion. Okay, I think we have discussed 7 sum and we have started discussing your sum number 8. In sum number 8 there are 2 parts. Okay, I will just go through in very short way what we did in part A. This is your part A's calculation. I'm just writing here, students. Okay, part A, this is the part A's answer. Okay, I'm just telling you in very short. The question I will dictate: a flask of volume 5.00 into 10 to the power minus 4 meter cube at 35 degrees C is made of glass having alpha equal to 4.5 into 10 to the power minus 6 per degree C. Find, what was the first part? Find the contraction in volume when it is placed in ice cold water at 0 degree C. Okay, so that we have discussed here, and now we have to calculate the part B, that is you have to find out the temperature at which its capacity is 5.003 into 10 to the power minus 4 meter cube. Okay, so from this and from the part A, what we calculated, what we have calculated the V2 minus V1 part, that is the contraction in the volume. So students, a contraction of this value corresponds to a cooling of the flask by 35 degrees C. That means since your flask is getting contracted, then you can see that this contraction is the effect of the cooling of the flask by 35 degrees C. This is your 35 degrees C, the change in the temperature, isn't it? Therefore, an expansion of 3 into 10 to the power minus 7 meter cube will be caused by a rise in temperature, isn't it? So yes, now what we have to do, that an expansion, repeating once again, an expansion of 3 into 10 to the power minus 7 meter cube will be caused by a rise in temperature. Now your flask has been expanded, isn't it? So let's write that value. So part B, so I'm just writing the statement: a contraction of 2.362 into 10 to the power minus 7 meter cube corresponds to a cooling of the flask by 35 degrees C Okay, so therefore students, an expansion of okay, let me write the next statement, then I will explain. Therefore an expansion, I'm just writing exp means expansion. Okay, an expansion, okay, I'm just writing here, an expansion of 3 into 10 to the power minus 7 meter cube will be caused by a rise in temperature, isn't it? Okay. Why, students? Let me explain you all this step. Why we are writing this? See the volumes, the two volumes value. Just in the first part of the statement, what has been written? A flask of volume 5.00 into 10 to the power minus 4 meter cube. Okay. Is made of glass having alpha's value so much. And what has been given in the last part or in the part B's question? That is, you have to find out the temperature at which its capacity is 5.003 into 10 to the power minus 4 meter cube. That means you have to just do the subtraction and you have to arrange it in such a way so that it looks like this. 3. That is completely up to you, how you are going to represent your numbers. So just finally, what is the main thing that you have to do? For the expansion means you have to do the subtraction. Clear? So our result for the subtraction and after arranging it, it will come to as 3 into 10 to the power minus 6 meter cube. So let's write the value. That means the expansion will be that value 3 into 10 to the power minus 7 into 35 divided by this part v2 minus v1 part, that means 2.362 into 10 to the power minus 7 per degree C, which is equal to, now you have to calculate this part. It will come to nearly, okay, it will come to after 44.5 degrees C. Okay, so after getting this value, that is the expansion's value, what you can say, hence the flask must be heated to 35 degrees C plus 44.5 degrees C. Just add it up, you will get the final temperature. Clear?